Good morning, everyone. Thanks for coming by this morning to hear our talk today about the state of the streaming platform in 2016. Start out with the obligatory bio slide just so you know who we are. I'm David Tucker. I'm the Director of Partner Engineering at Confluent, the folks that actually bring you Kafka every day. And then David Ostrovsky has been working with me from Couch, and he's a senior solution architect, the man who literally wrote the book on a lot of the things you'll see around Couch and other database things. It's been a real privilege to work with him over this, and the demo you'll see at the end of the talk here is wholly David O's work. And so if you need to refer to either one of us at the end of the talk, I'll answer to Tucker. It'll be a little bit easier. If you say David, then we'll know who you're talking to. Kick off a bit with a quick query in the room. How many of you have heard of Apache Kafka? All right, I like that. I like that a lot. How many of you are using Apache Kafka in some environment today? And of those, how many have it in production for something that's using? Fantastic. I mean, this is what we love to see. That's actually what we see at Confluent, and one of the reasons that we're working so hard to expand the capabilities of the platform. Because as those of you who work with Apache Kafka know, it's a heck of a lot more than just a pub/sub system, right? Initially, that was the goal. You had this problem space that existed at LinkedIn and many other enterprises. Lots and lots of ad hoc data pipelines and a real problem integrating different data systems and integrating applications into those data systems. And so the model of Apache Kafka, I'm not going to go into any details today. You guys are probably all familiar with this, a distributed commit log, right? A guaranteed ordering of events as they pass through the system, the idea of Kafka topics and how those scale to producers and consumers. All really powerful. And what you get once you actually put that kind of platform at the center of this hodgepodge of data pipelines is something that looks like this, but it's much more than simple publish subscribe, right? Our view at Confluent, and actually at Couch as well, of what a streaming platform is first and foremost that distributed publish subscribe capability, but a persistence layer underneath it. So that is the messages and events are stored for retrieval at whatever point. You don't want to have the consumers need to be online at the time that the publishers publish data. You don't want to have the risk of a publisher going offline or crashing and somehow resulting in inability to access that data later on by another consumer. And so that's one of the real strengths of Apache Kafka. I can decide how long I want to retain data in a given topic. That can be different on different topics within the same cluster, and I can then consume that data whenever it's appropriate. And that publish once, consume as often as I want model turns out to be really powerful. You land the data where it needs to be and where it is adding the most value. But the last piece of a true streaming platform is this idea of in-stream processing, right? Lots of times you need to be able to event by event, do some level of processing and analytics against that data as it's flowing through your system, rather than having to land it all the way out. And so we'll talk about that as we go through all of the different pieces that comprise what we see now as a true distributed streaming platform built on top of Apache Kafka. Because when you think about the evolution of the big data environments these days, right? Originally, there was this idea that more data was better, right? Big data meant more data. You consumed, you basically stored as much as you could possibly handle inside these big Hadoop systems, and it became cheaper and cheaper to retain more and more data. Fantastic. But the processing of those things was often batch, often very slow comparatively. You were dealing with larger volumes of data, but you still had this batch-oriented model for processing it. And so then this concept of stream data arose, and that the time value of the data was very important. So you wanted to be able to process that data as close to the point of creation as possible, right? And so a couple of models evolved around that, but one of the more popular ones, and you hear a lot, and it was really big in the various conferences for a couple of years, is this idea of the Lambda architecture. And that way you sort of had to choose, big or fast, right? So you would land, data would be streaming in, and you do some landing of that for the long time archival and larger capacity storage, but then you do some batch-oriented work on that. And for the stuff that was real-time response, a real-time application, you try to do that in stream, and you'd have this speed approach. And actually, Couchbase is fantastic for that, right? Couchbase gives you that very speedy response to as fast as data can be ingested. But now we see this new model, this Kappa model, where you need to be able to support big and fast. It's streaming data in your enterprise. You need to have a consistent view of the stream as a series of events, and potentially as a materialized view, a static table of my position of risk within a financial instrument, or my current user profile, right? And so that's where the idea of a complete stream platform comes up. You need to be able to support all these different use cases, all these different application models, and in order to do that, what Confluent has done is built up a set of services and components on top of Apache Kafka. Now, this isn't potentially the only way you could do this, but remember back to my initial points about what it takes to really deliver a streaming platform. That distributed publish-subscribe model, very fault-tolerant, very secure, a storage layer that's persistent, allows you to store data for as long as you need to, not just 7 days, not just 7 hours, and lastly, a processing piece. And we actually feel that Kafka delivers all of these things, and then we build a couple of other components on top of it, some of them open source, as you see there in the second line, and some of them commercial. We're going to talk about these and how they contribute to your successful deployment of a streaming platform, and more importantly, how Couch gets leveraged into that whole environment, because there's always the requirement to persist data to an analytics layer, right? There's always that need in your streaming data systems, and we think Couch is fantastic for that. So let's go back to that first question, right? How do I get streams of data into and out of my applications, right? And so there's a couple of different ways you can do this with Apache Kafka. As all of you raised your hands, the legacy producer-consumer model is very easy to implement. It takes about 20 seconds to create one of those and write them up. But we actually wanted to extend that a bit, and so did the community. So the community has developed the Kafka Connect framework, and on top of that, Confluent has built some supported connectors, and if you listened to Will's talk just before this one, you heard about the Couchbase connectors. We'll talk about that a little bit later on as well. But the idea here is that instead of writing code to build out your data pipeline, what you can do is just configure some pre-developed sets of connectors in order to produce messages, source them onto Kafka topics, and sync them, write them back off later on. And as long as you have a consistent framework by which both the syntax of the data flowing through the system can be well-defined and agreed upon between the connectors, and the execution model of the connectors, right? The heavy lifting of making sure that the individual tasks are resilient and get restarted in the event of a failure or things like that is all handled by the framework. And so what you now have is, instead of the need when building your data pipeline to write your own code for each and every one of the potential data sources you might want to use, instead, you simply enter a few configuration parameters into a JSON doc, and poof, you have a JDBC source connector extracting a table from your MySQL instance, a Couchbase source connector extracting records from individual buckets, or a HDFS sync connector writing records one line at a time into HDFS, potentially with Hive integration to do database querying back there. All of that without writing a line of code. And so what you'll see in the community of Kafka Connect is a wide range of different connectors for different data systems. Some of them end-user applications, Salesforce, Bloomberg. Some of them more traditional NoSQL and NewSQL sources, the VoltDB guys. Lots of JDBC endpoints, Postgres, all those things. And so that makes it far easier for you to build on your streaming platform a data pipeline to move data from point A to point B resiliently in any way you want to. So the next piece, when you think about getting data into Kafka from your applications, is the idea of an actual client, right? If I am going to write code, and some people love to write code, I actually do too, you might want to write things in Java and Scala. That's what the Kafka community has developed the source code in. But we at Confluent, and actually others as well, saw lots of need for other languages and other support within the client side. So if you want to write a C application or a Python application or Go, these days lots of .NET frameworks or PHP, any of those things. There's a whole set of client-side offerings and client libraries to enable you to push data into Kafka and pull it back off again if you need to. And so we think that's, again, sort of a fundamental part of your streaming platform, because if the only way you can get data on and off is via some proprietary interface or one language, then that's really not the way you want to put something in the center of your enterprise, right? You want to have the flexibility to be able to do things the way your developers or your teams are used to and to integrate them properly. And this last piece here, the idea of a REST proxy, is actually what we think of as one of the more important pieces for integrating Kafka, that streaming platform, into the center of your enterprise. And that's the REST proxy. So if you think about the number of applications that don't necessarily give you the ability to add new Java code or add new C code into them, but still have the ability to get and post from an individual REST endpoint, those are all the capabilities you need to integrate with Confluent's REST proxy into your Kafka environment. So I can literally find out what topics are available, post an event to a given topic, retrieve it back, and it's integrated in with the Confluent Platform Schema Registry, which I'll talk about in a second. But it actually means that any application, no matter how old, no matter how constrained, can still potentially retrieve data from your Kafka environment or post data up to it. I mean, we've had folks literally, frighteningly, in COBOL sending a message up to the Kafka topic and making it work, right? And so if you can support COBOL, you can pretty much support anything. So the next thing to think about, right, once you've got data onto and off of your streaming platform, is how do I maintain the data format and ensure compatibility, right? Those of you who are familiar with Kafka know that there's this concept of serializers. Data is serialized as it's posted up into the Kafka brokers and deserialized as it's come off. Turns out that if you leverage that point of access within the Kafka protocol, you can actually very powerfully manage the schemas and the data syntax of the individual topics. And so that's what we've designed in a schema registry. It's effectively a contract, right? When I publish data to a particular topic, I say, this topic has this schema as part of it. And so now if I go later on and try to publish data that doesn't match that schema, the serializer gives me a warning. Now, obviously, I could configure things such that, nope, this topic is wide open. Anybody can publish anything they want to it. But in an enterprise, what you'll often find is that what you want to guarantee is that once a given topic is defined as part of a data pipeline in your enterprise, the syntax, right, the underlying data format and structure, you need that to be guaranteed so that when the producers who are writing the data decide to add a new field to the data structure or some new set of data, it doesn't automatically disrupt all the downstream consumers, right? And so by enhancing the serialization with this schema concept, I can enable that. I can say this topic has this schema. This schema is defined such that it can be forward compatible. That is, I can add new values to it as long as, say, there's a default value for that new column type in the schema. And now downstream, the consumers, they can consume the messages. They see the quote-unquote old data, the original schema that they needed, or they can potentially uplift, project it into a new version of the schema if they want to. All that is available to you as part of the serialization layer. And so when you, and the serialization pieces are pluggable. So that is, if you don't want to leverage those features, fine, use the legacy serializers from the Apache Kafka environment. Or choose, for example, the JSON serializer that carries that schema information along with each and every record. Doesn't necessarily require an external schema registry, but still allows you to maintain nice, consistent schema across the messages. Or go all the way and use the Avro serializer that actually leverages an external schema registry, achieves better data compaction across the events as they're traveling through the system, and still gives you that same capability of managing the syntax of the message, leaving you to do the real work, right? The semantics, the meaning of the individual fields is still up to you and your applications. but enforcing that syntax makes for a lot easier time integrating applications. That schema registry piece, the enforcement of the schemas and things, is fully integrated into Kafka Connect. So your connectors can take advantage of that if they want to, or by choosing older serializers, don't need to. Right? The last piece here, right, for the streaming platform is this idea of how do I build a stream processing application, right? And so beginning with Kafka 10, there's a new feature within Apache is Kafka Streams. That is a pluggable, it is a simple Java library that allows you to create new applications that process the events as they're flowing through the Kafka topics event by event. There's both a domain-specific language as well as a lower-level API. And it actually means that you can focus on the stream application rather than the execution framework into which the application will be deployed. You get to pick that later on, right? But when you're developing the application, and David O will show you that at the end of the talk when we go into the demo, it's very simple to use the Kafka Streams DSL to pull data off of the topics you want, to process it in whatever way you want to, and then potentially push it back onto Kafka, write it out wherever you need to. And the next slide shows a bit of a breakdown as to what the before and after state of stream application development was, right? So if you look at the way a lot of systems built out stream processing and integrated in with Kafka, is you would have some external execution framework, Spark, MapReduce, something, that would grab the events off of the Kafka topics. In many cases, they had to do it in a micro-batch manner. You'd have to grab a set of them before you could start the processing. That would be distributed, so you had little or no control over how your application was parceled out amongst the execution framework, because those execution frameworks, very powerful, and importantly so, but you had, as an application developer of a streaming app, had sort of less control over that. And then when when the data was finally processed, often folks would then persist it out to a relational store of some kind for later querying by the app, that actually where the downstream consumer of that stream processing framework was talking to yet a third layer in this whole picture. What Kafka Streams allows you to do is it's a much simpler application-centric focus. That is, I write my K-Streams application. It's running in my JVM, right? It uses the same consumer group model that Apache Kafka has as part of a framework, so it will scale. So if you have another execution framework whereby I spin up 7 copies of my JVM running my Streams application, it does the same thing that the consumer group model does within Apache Kafka in terms of balancing out the topic partitions and those things across those individual JVMs. But the nice thing is that your app, that K-Streams, is just a Java library. So you've written your application logic, all running right there inside the JVM, and the materialized views of your results are either published back to other Kafka topics or persisted as queryable tables within the application. And so there's this concept of queryable state that's been introduced with the Apache 10.1 release a few weeks ago that allows external applications to literally execute, give me the current state of whatever materialized view, the table representation of my running Streams application is inside K-Streams, and pull that back out. So instead of having 3 different layers between me and whatever I'm visualizing for my stream processing application, I have one. A much simpler approach, and you'll see some of that in what David O has done with a K-Streams application for today's talk. So let me go, the last piece here is around how you would monitor and manage that streaming platform, right? And this goes to some of the commercial offerings that Confluent has, because there are lots of different alternatives for measuring the speeds and feeds of your Kafka deployment, right? I can have lots of different systems that will show me what the CPU utilization is, what the disk utilization is, all those other kinds of things within my Apache Kafka cluster. But if what I really care about is, did a message that was produced by this client make it all the way through to the consumer that I expected it to, right? How do I track the latency topic by topic as I go through as I pass through that streaming platform? And so that's what the Confluent Control Center is designed to do. It does end-to-end monitoring of each and every one of the topic partitions, gives you direct visibility if a particular topic partition is falling behind, hence maybe one member of a consumer group is falling behind and having difficulty keeping up with the event stream coming in. If there's an inadvertent spike in latency between the producers and consumers. And so all of that is done transparently to the application, right? We have some basically logic inside the Kafka client layer that allows you to inject interceptors into the clients, and transparently information about the latencies of the events as they go through the system is collected and then displayed up in the control center. Ironically, the Confluent Control Center is a Kafka Streams application. What's happening is behind the scenes, all that data from each and every event flowing through the system is being aggregated inside Kafka, processed as a K-Streams application, and then visualized with this front end. But what's really important here is that by tracking the messages natively within Kafka, I can get visibility into things that the other tools don't let me see. So for example, if I may, in some cases, have 10,000 messages produced and what looks like 10,000 messages consumed by a downstream consumer, but in reality, the producer may have had to double produce, double write out a couple of things because there was a hiccup in the network, and the consumer may have seen messages delivered more than once. Those kinds of things are very hard to detect using the JMX metrics of Apache Kafka, but with Control Center, we see that. There's actually checksuming going on, so you know a particular message did or did not make it through the entire system. So those off by one errors or intermediate message delivery problems can actually be detected and identified. The other piece actually two other pieces that Control Center allows you to do. First is connector management. We'll see that with the demonstration at the end of the talk, where you can sort of configure a connector for deployment within the cluster and then watch how it's running for things, again, giving you a nice visual interface for entering the configuration parameters rather than having to type it into a JSON document and do a REST request up. And lastly, it gives you some visibility into multi-data center management and replication. So a new feature with Confluent Platform 3.1, released just today actually, if you want to go to your website now while we're in the talk. It's the ability to replicate data cleanly from one data center to another in a reliable manner. It actually leverages the Kafka Connect framework, and so has a much better exactly once delivery semantics for replicating not only the topic data, but also the ACLs, other kinds of access and metadata information about the topics over to a remote cluster. So if you have a production environment and you're worried about disaster recovery, you're worried about maintaining the integrity of the system as you're expanding it in your production use case, this is really important. This multi-data center management, the replicator service in between clusters is pretty helpful. One last piece here, obviously none of this would be as useful if you didn't have the ability within the system to alert you when there were problems, right? All of these things are really nice when you're sitting there watching them on the screen and you can see, hey, this topic is sailing along with 3 milliseconds latency and that topic is sailing along with this much bandwidth going through the entire system. Instead, if what you want to do is actually get some alerting to those things, and you can actually do, those alerts are new with Confluent Platform 3.1, and it allows you to configure sort of emails when certain triggers happen within the cluster. So you can make it very easy to track, to identify problems around latency decays, around data delivery issues, the connector the status of individual connectors and things within the framework. And you have that ability, obviously, on a user-by-user basis, right? I can sit there and say, hey, this user should be notified, or this user's connectors need to be tracked in this manner, and the others don't need to. So I'm going to pause there for 1 second and let David O set up his demo for things. Actually, I apologize, David. I do need to do one thing on the demo. We had that slide that we worked on last night just to give people an idea of what they're going to see in here, so that instead of just looking at the IDE screens, you'll see a little bit about what's going on. So there's actually a complicated data pipeline going on here to leverage a lot of the different capabilities of both Couchbase and the Confluent platform. So we're using a Twitter connector to go out and suck in a Twitter feed into our Kafka topics. And so that's, instead of writing code, that's a few simple parameters and David O's Twitter authorization, and poof, we can get Twitter data into a Kafka environment very quickly. That topic is then consumed by a Kafka Streams application and augmented with some sentiment analysis data and written back out to Couchbase. And from there, the Couchbase the Couchbase source connector from Confluent platform again is used to pull it back in. We do a second round of processing. So imagine a multi-cyclic application that you'd want to do for your stream data pipeline, and we pull it back in, do a second round of processing, doing some geolocation identification. That information is spat out and saved in Elasticsearch. And so now with Elasticsearch, you can then visualize both of the geolocation information around where people were tweeting and some sentiment analysis around the tweets and get some pretty powerful analytics. The somewhat complicated picture of all of that, and there will be a quiz at 11 o'clock for those who need to remember this as to what's going on. But you sort of see the data starts down here at 1, comes into the Twitter source connector, comes onto Kafka, goes out to the K-Streams app, goes down once into the Couchbase sync, jump back over to the left-hand side of the slide here where it comes back in from the certified Couchbase source connector as that step 5, back up to K-Streams, and then finally out to Couch and Elasticsearch again. So this is definitely more complicated than you might want to have done in a production kind of environment, but it illustrates a lot of the capabilities of the platform. And that's what we're trying to do, to show you how the connectors working together with the K-Streams application, working together with the control center for visualizing what's going on, working together with Couchbase can give you something pretty powerful. So I'll hand it over to David O.
All right. So hi, I'm David, also David. We have a thing at Couchbase about hiring Davids. It's a major plus in your application. So when we started talking about this demo and what we're going to actually show with Kafka and Couchbase and how we can show this, we had 2 goals, right? Obviously, show all the different cool things you can do with both, and also try to do something that's actually real world. And obviously, analyzing tweets is not really a real world application for data streaming, but we did gather a few use cases that are very common with clients that I see for doing streaming data analysis, right? So bringing in tweets and then just doing some ETL and putting them in a data store is analogous to a lot of things you see in the real world, which is you have a streaming data source from somewhere, and you want to put that stuff in your data store, but you want to do just some minor, very low latency processing on that before it goes in the data store, just to make it easier on yourself to query it or maybe use it somehow later, right? And this is the first part. This is what we do, right? We bring in tweets, then we do some processing on the fly and put them in Couchbase as quickly as possible because we want to expose those to be queried as quickly as possible. We don't want a whole very long data processing pipeline before the data lands in the data store. But then we do want to do a bunch of very very high latency, very CPU intensive processing on this data. So you have to cycle this around and actually stream the data from the data store from Couchbase. And Couchbase is one of the databases which has the easiest way of actually streaming data in order of it being written, right? And that's what the connector, the source connector for Couchbase does, which is just stream data from Couchbase and into the pipeline. And then we can do a bunch of processing on that and then cycle that back into Couchbase. And the reason it's really cool to do with Kafka Streams and why, for example, I'm very excited about Kafka Streams as opposed to, let's say, Storm or Spark, which I've worked with quite a bit, is one of the cool things about Kafka Streams is it's not opinionated about how you run this, right? It doesn't force you to use a certain orchestration mechanism. It's just a Java application, and you can deploy that with any orchestration you want, right? If you want to use Docker Swarm, you're welcome to do that. If for whatever odd reason you want to use Yarn, you can also do that. And for anyone who's actually had to struggle with something like Storm's resource management or trying to set up Spark clustering, which takes weeks, believe me, it's very refreshing to be able to just have an application which you can debug, you can run it locally, do whatever you like with it, and then also just deploy any number of instances of that application, and it just works, right? Magically, so to speak. All right, so without further ado, let's actually look at some code and see some stuff working. And I'll have to warn you, as with all live demos, things will probably break horribly, but hopefully you'll forgive me. All right, so just to go over the moving pieces here, right? So we're gonna first of all start things off with connecting to Twitter and streaming some tweets. Hopefully we'll actually get some tweets in. Now, I know the election is over, but we needed to find some keywords for Twitter to actually produce lots of tweets. So we're going with some politically motivated tweets. I encourage you not to read any of those because people, especially people who tweet about politics, are just really terrible people. So we'll avoid looking at the tweets. We'll just know that they're there, right? So first of all, we need to create a source for our Twitter connector. Right? And we have several ways to do this. We can use the UI, and I'll show that in just a bit. But for the Twitter connector, it's just a lot to type, and I'm lazy, so I'll just do a quick REST request to create the connector. It's just because the Confluent platform lets you do all kinds of things, including controlling it from command line, from REST, or from the UI. I can do both, so I'll actually show both. First thing we're going to do is tell it to create a Twitter source with my Twitter credentials. It's being recorded, so you can go back to the recording and copy and tweet in my name. And that's it. That's all I had to do. If we go back to the Confluent Control Center right here, suddenly we see that it actually created a new Twitter source connector. And right now, there is a Kafka topic called tweets, which is being filled in the background, right? Being filled very quickly. If we look at the tweet source definitions, we can see that we have a few keywords which are, well, unfortunately out of date. I mean, now it would have been relevant yesterday. But the important part is it's going into a topic called tweets. And the topic is now growing, but there's no one consuming this topic, right? The topic is it just sits there and gets filled up, and we can leave it to run forever, basically. And there's no throttling, so it will fill up very quickly. So first of all, let's actually, let me prove that there is stuff going into the topic, right? So let's consume it real quick. Which means we can actually create a very quick file sync to dump the entire topic with tweets onto disk. So let's take our tweets topic. And we have a lot of different connectors we can use to actually sync this data into. And as you can see, there's Elasticsearch and HDFS and all kinds of things. But we'll just use the file stream connector sync to just dump it to disk very quickly. It will go to TMP, let's say, file.txt, right? Because I'm lazy to type something more complicated. And now suddenly we have the topic being consumed, right? And I didn't have to do any coding or anything like that. And now we have tweets coming in, getting stored on disk. And let me prove that it actually is going to disk. So let's go over here. And there we go. We are getting more and more tweets. Well, there's no way you can read this, but you also shouldn't. All right, so tweets are happening. Excellent. First stage is accomplished. But now this is actually sitting in a Kafka topic. So how do I get from that to putting some stuff in Couchbase where I can query it and do interesting database stuff with it, right? So first of all, let's pause the Twitter source because it has no breaks. And it's going to fill up my disk very quickly, as we've discovered, unfortunately, last night. So I'll just pause this for now, and you'll believe me that the tweets are still happening out there in the world, right? Because there's no way to prevent people from tweeting. All right, so now what do? We want to connect to this topic and do some ETL, right? We want to do some processing because I don't want to just take the tweets as they are and put them into Couchbase. They have a lot of metadata attached to them. There's a bunch of useless info. And a lot of the tweets data is not in a format that's convenient to use because I know that later I want to push this stuff to Elasticsearch, which, for example, expects geo-coordinates to be in a certain format, which is exactly the opposite of what the Twitter source brings in because it reverses the latitude and longitude for whatever reason. So I want to do some very lightweight processing, but I want to do it quickly and just land this stuff in Couchbase as soon as I can. So this brings us to our first Kafka Streams application. And I'll just zoom in so you can see this a bit better. Is that all right? Everyone can see it? Should I make it bigger?
Looks like they're good.
Yeah, we're good. OK, so Kafka Streams application is a very simple Java application. All I have to do is reference the Kafka Streams libraries, and then just provide a few configurations which actually tells the Kafka Streams application where to find Kafka and Zookeeper. So this is exactly what we're doing. The application ID defines the actual group, the consumer group, right, that the application belongs to. So if I have several instances of this app running, they will all connect to the same consumer group and be able to share the data. Right? This is how it's actually very easy to scale. As long as I have enough partitions in the topic to have enough applications connected, I could have any number of applications consuming my topic in parallel. And how I do that parallelization, as I said earlier, is not Kafka's concern. It's up to you, which is really a good part here. All right, so we're going to bootstrap off the local server, and our Zookeeper is also running locally. And we'll skip all the rest of this stuff, because that's not what we're here for. What we want to get here for is where we actually get the tweets from the Twitter topic, right? So this is the part where it starts getting interesting, right? We were consuming the tweets topic, which is the topic that's getting filled in the background by the Twitter source. And we just want to do some very simple stuff. First of all, we want to deserialize that, because by default, the Twitter source actually serializes those as JSON with schema attached. Now, we don't need the schema, so I'm going to throw it out. I'm just going to take each one of the messages coming in, deserialize that as JSON, which is essentially just, if you want to go in Java, is just a map, right? It's a map from strings to something. And then I just want to fix the geo coordinates. That's all I want to do, and then I want to put it in Couchbase. Now, in order to put this in Couchbase, I just use the Couchbase SDK from Java, which is very simple to do. It's like one line of code. And here, in our JSON of the tweet, we throw out everything we don't need. We just keep the payload, which is the tweet itself. We reverse the geolocation coordinates in the correct format. And then the next stage in the pipeline after that is to simply save it in a database. And that's all it does, right? And when we save it, we print out a message just so we actually know that something has been saved in Couchbase. This is all we do. So let's run this, and hopefully it will actually work. Nothing is guaranteed in live demos. But as it happens, luck is with us. And we shouldn't examine this too closely, but it works. And now tweets are happening, and they're going into Couchbase. So how do I know they're going into Couchbase? Well, let's prove it. Let's go over to our Couchbase dashboard. And we can see that, yes, we're getting about 200-something tweets per second. And my laptop being a little slow means it's probably overloaded at this point. But that's not the point. The point is things are happening. Right. And this is the weak part in all demos, right? Docker has actually crashed. But that's all right. We'll bring it back. It's good. It's good. And we'll see that nothing has been lost. Nothing of importance has been lost anyway, just tweets. But we'll be back in a second with Docker. There we go. Excellent. It's back. And we can run Elastic as well. This is why I both love and hate Docker. It works really well when it works.
And he's putting a pretty heavy load on that one Docker image. It's doing a lot of stuff. In a real world, you'd have a cluster behind all this.
Yeah. All right, so Couchbase is back, presumably. Let's see. And it is indeed. And let's log in and see that we actually do have some tweets. And in case you're wondering, the password for that is 12345, just like my luggage. So let's take a look and see if we actually have the whole thing loaded up now. It will eventually hopefully work. Let's try this again. Bear with me, folks. Stop Couchbase. Let's run again. And hopefully this one will actually start properly. Let's take a look. It isn't. And that's the danger. Oh, there we go. Excellent. And it's working now? It is. Soon enough. But either way, in the meantime, we still have our application running. So let's stop it for now. So the next part would be to actually take some data, the stuff we put into Couchbase, and actually consume that, right? And hopefully, once Couchbase loads, we'll be able to do that. It is not. Let's try it again. Last try, I promise. Let's go. Let's see if it actually loads. And it'll take a second. All right, so the point is we have all our tweets in Couchbase, and now if it does in fact work, it does not. It's not logging up. No, it's the only node. Seems to be all right. Okay, so we can try this differently. We don't need to save the data. We'll just run this without the folder. Should be fine. And then we can actually recreate the bucket and try it again. We still have a few minutes, so that should be all right. There we go. This is all fine. We'll just quickly set up the cluster. You can skip all of this. We do agree to do that, and again, 1, 2, 3, 4, 5, 6. Excellent. Let's create a new data bucket. Let's call it tweets. Very good. Okay. Hopefully this will actually load and not. There we go. Excellent. So let's run some tweets into that new bucket called tweets. And hopefully we'll actually have some tweets. No, we do not, because we don't actually have any tweets. So let's run some more tweets.
We just start him up again, I think. Just start we had paused.
Oh yeah, you're right. It's actually paused. There we go. Now we should have some tweets coming in, one would hope. There we go. Excellent. All right. So now we can finally prove that we do in fact have tweets. Let's look at one of them. There we go. We have location and all that stuff. So now let's consume those tweets from Couchbase. And obviously it's going to be just like that in production. So now we want to create a source from Couchbase to our processing application. So let's do that with the UI, because we can afford to do that. Let's create a new source. It'll be a... Sorry? No, let it run. This is going to be a Couchbase source. It's going to be from Couchbase server called Couchbase, and the bucket is called tweets. We'll just, the topic name is going to be Couchbase, and all we have to do is run this, and now we have a second topic called Couchbase being filled from the Couchbase bucket right back. So I can also prove that it actually works by going to the file, sync, and doing that. But instead, let's actually run an application which will consume the Couchbase topic and do some processing. So let's go to our second Kafka streaming application. And it does something relatively simple, right? It connects to the Couchbase topic right here. It pulls every tweet. It, again, deserializes that from Couchbase, because Couchbase also provides JSON objects. And then it does very simple sentiment analysis. I'm using the Stanford NLP library, which is free. Everyone can use it. It does a bunch of really cool stuff with text, including sentiment analysis. Now, obviously, longer text gives better results, but tweets are what we have to work with. So right now, all it does is take every tweet that comes from Couchbase, apply the sentiment analysis, which is this one line of code right here, and then just add that field as a new field to the document. We have two fields. One is sentiment score, which is the integer from 0 to 3. And the other one is the text interpretation of that, so negative, positive, whatever the sentiment is. Right, we add this to this document, and then we do two things. One, we branch off another stream of just the sentiment values with the document ID, with the tweet ID, and publish that to a topic called tweet sentiments. And anyone who wants to get tweet sentiments can consume that and do some analytics and process that. And we also, at the same time, have a second branch going off that stream, writing back to Couchbase and doing updates on that same document. So let's run this. Sorry, Stanford NLP, Natural Language Processing Library. So we run this, and hopefully this will actually work. It does, but you'll notice that it goes much slower than the tweet consumer, right? Because tweets are getting in at about 1,000 tweets per second. We're able to read them off the topic and write it to Couchbase at about 300 per second. And we're able to do something like 3 or 4 tweets per second from Couchbase to our NLP processing library, because right now my laptop is going very warm and it's eating up all my 16 cores because NLP is very CPU intensive, right? So in the real world, I would have probably 10 or 20 instances of this Kafka Streams app for every 1 instance of the ETL Kafka Stream app running, so I can actually balance the load correctly. But how would I know that how many instances I need? And this brings us to the coolest part, and that's the last 5 minutes of our talk, which is how do we monitor all of this very intricate, very cool stuff, right? So 2 things. Let's go back to our, I'll turn this off if you guys don't mind, because I don't want my laptop to melt, which is a thing that happens. It's not made by Samsung, luckily, but it might still melt just because. All right, so now we can go to the monitoring part, which is right here, data streams, and we can look at not the last 4 hours, we can look at the last 10 minutes. And David, help me out here.
Where the consumer should have showed up in here. Let's do a hard refresh of this guy.
Yeah. So in an ideal world, we would actually see a graph of messages coming in and latencies.
I think the hiccup on the on the Couchbase side made this guy unhappy because he's not seeing anything there.
So let's try this again, and we'll run all the.
Because the file consumer is still going, correct?
Yeah, it is.
Okay.
Yeah, things are happening still. Let's take a look at the connector. Connectors are still working.
Right.
So in an ideal world, we'd actually see a graph of how many messages per second are being produced, how many are being consumed, and more importantly, what is the latency between a message getting produced and consumed. And what we would have seen here is that for every message produced in the tweet topic, there is an increasing amount of latency for the Couchbase topic, because we produce tweets very quickly, but we consume them for the sentiment analysis much slower than that. And we'd see latency going up quite steeply, and eventually we'd need to handle this, right, by adding more of the stream processing application. And now that we have all of these tweets in Couchbase, the question is, why did we put them in Couchbase in the first place, right? Couldn't we just do all this stuff in Kafka? And for some things, the answer is yes, right? You can use Kafka tables for doing a lot of aggregations, but there are things that are just database things which you want to do. For example, let's find all the tweets where the sentiment is positive, right? So we can do, let's make an index on the tweets bucket, and then we can do something like select from tweets where score equals 0, which is very, very negative. And then there aren't any. Amazing. How about 1, which is just negative? Oh, we have a lot of those. All right, and so we can actually go and see a bunch of tweets, right? And in case you're wondering, what is the average sentiment score of a tweet on the internet? It's pretty negative. So how do we know that? But how do we know that, right? We've calculated all of those. As it happens, I can also now replicate from Couchbase to Elasticsearch. And this is a thing that Couchbase does natively. We can actually just replicate all of our tweets from the tweet bucket in Couchbase to Elasticsearch, which, as you can see, takes just a second to configure. And now we have all of this stuff going into Elasticsearch. Now, why am I doing this from Couchbase rather than doing it from Kafka? I could have done that from Kafka. There is a Elasticsearch sync. And for some things, it makes sense to do it in Kafka. For example, if I just want the raw data to actually be sunk into Elasticsearch, makes perfect sense. But in this case, I've done a lot of pre-processing on my tweets already, right? So I want actually to replicate the data I have in Couchbase to Elasticsearch. And this is a thing that we can do. We're replicating all of this stuff to Elasticsearch, which means we can bring up Kibana and look at a nice little dashboard of just what the tweets we have are. Hopefully this will actually work because nothing has so far. Seems to be okay.
Yeah. The podium is actually smoking, in case you guys are wondering back here. It's getting pretty hot on the computer.
So, yeah, I still have the sentiment thing running in the background, which explains why everything is very, very slow. But it will, in just a second, hopefully we'll get some tweets up here and be able to see them. Actually, now let's turn off the processing to make it a bit easier for everything. There we go. All right, so now we can actually have all of our tweets, and we have the locations being mapped, and we can count the tweets, and we can look at the average sentiment. And as you can see, we've only managed to calculate the average sentiment for tweets from quite a while ago, right? Because it's actually much slower than the tweets coming in. So if we let it run for a while and give it enough processing power, we'll see the average sentiment graph eventually catch up to the current time, because it streams tweets in the order that have been inserted into Couchbase, right? Because DCP, the protocol that streams in Couchbase, is ordered, same as essentially a Kafka topic. So we've started from way far back, and now we're trying to catch up on the sentiment. But the average sentiment is somewhere in the 1.3 area, which is between negative and neutral. It's more towards the negative, which doesn't surprise me because I've been on the internet. So that's pretty much it. That's the whole demo. And despite the snags on the way, we actually managed to get some results, which is impressive for a live demo, I think. Obviously, this is me patting myself on the back. All right. Well, thank you very much. David's going to wrap up. Let me switch over to the presentation for you.
I think that's a great summary. So if you think about all the different pieces of what a streaming platform looks like, and that's what the subject of this talk was to be, right? What's the state of the streaming platform? Think about all the things that David O just showed you, all the capabilities of integrating data into Kafka, processing that data, integrating it into other systems, either directly from that processing piece back into Kafka. Whatever the way you want to manage your streaming data, that's what you need to find a platform to do for you. And that's what we think we have with Couchbase and Confluent. So we're happy to take any questions for those who are still here. Yes?
It was a great presentation. Both of you did a great job. So my question is, in Confluent platform, if I'm enforcing the schema to Wrapup, and let's say it's writing to SDF as a file there,
Right.
and container-based as a file. So what are the best practices around evolving the schema? So there are different clients who are sending, all of them you cannot upgrade at the same time.
Right. So the question here is, if you're using Confluent Platform and the Avro serializer that leverages the schema registry, and you're landing into something like HDFS, how do you handle the evolving schema? What's the best way to do that, right? Some of the connectors, notably the HDFS connector, will adapt to changing schemas from the incoming sources. That is, if they're consuming from multiple topics, and the HDFS connector is designed to consume from multiple topics, it will see the evolving schema and then make that change and update Hive metadata or as appropriate inside systems. If you think about, you get to choose on the producer side, the source side coming into the topic, whether you want to enforce backwards compatibility, absolute compatibility, no changes whatsoever, or forwards compatibility on the schemas. And so a best practice in our world is ensure that as long as the schema evolution is backwards compatible, that is, if I add a new field to the schema, but it's got a default value, that's fine, because the downstream consumers are going to have, they're going to see the schema and it's versioned in the way that we manage the schemas for the serializers. They're going to see, oh, this record has a new version of the schema, but it's compatible with the version I'm used to. Fine, I'll do a projection and I'll only mess with the data that I care about. So an arbitrary consumer of that data would handle it that way. The HDFS actually knows how to evolve it. So some of the more powerful connectors will adapt to the compatible schema changes as they go forward. Did that answer your question?
Yeah, partly.
Okay.
I'm actually more concerned about if you are already writing to SDFS, the schema went in the beginning of the file.
Oh, so if you're talking about, say, writing out a Parquet file where the file types.
No, you
that-
know, you're
oh.
writing a file and this file actually has a schema in the beginning.
Okay. Oh, and so let's talk about that offline because there are ways that you can handle that. But you and I can talk after the discussion. Yes.
So when you set up the Couchbase source connector, how much configurability do you have in terms of like, inserts or updates, like modifying the schema of the document to some different schema that you might want on the Kafka message you're producing?
So the Couchbase source connector doesn't care about any of that. It just uses the DCP protocol to stream raw documents and inject them into the topic, and it's up to you to handle them. You'll notice that I did most of the handling in the actual Kafka Streams application, because I can write code and handle a lot of the things. I can actually inject meaning into the schema of the document, right? What I get from Couchbase through the Couchbase source connector is just the raw document serialized to JSON, right?
And the gentleman 2 rows behind you, Sergey, is writing the Couchbase source connector. So if there are things that you need out of that, between him and me, we can work together to get that implemented.
We might add, there is
Yeah.
some schema in there, and then we have metadata
Yeah.
from Couchbase.
Yeah,
Dave's
so
absolutely right.
those guys put a lot of thought into how you can actually inject schema into documents which come from a schemaless source. So you really want to talk to Sergey.
So,
Good.
so is there a different way or more programming to do when you do go with the Cloudera?
So there are lots of other folks that distribute sort of that core Apache Kafka broker piece, right? Remember that picture of what the streaming platform is in terms of the Apache, what Apache Kafka delivers you brokers and the Kafka Connect framework, no connectors out of the box and things and K-streams. So yes, you could take any of those components, the schema registry component, a Kafka Connect worker from Confluent and target it against an arbitrary Apache Kafka cluster that you might want to deploy, right? Now, what you'll get from support from folks other than Confluent is sort of between you and that sales rep. I suspect that in most cases, they're not as interested in keeping the streaming platform the center of the enterprise. They want that static Hadoop space to be the center, and so it's a little bit less in their interest to support those other pieces.
Guys, we have to wrap up because
Okay.
we're over time now, but we're happy to answer questions.
Yes,
if
we'll
you wanna
stick
come
around,
over.
and thank you all.
Thank you.